Hi, thanks for taking your time to watch this video. Let's start the topic nuclear propulsion. During the 1950s, much of the world was wobbling with anticipation over the exciting prospects of nuclear power. Nuclear energy originates either from the splitting of atoms, a process called fission, or by merging of atoms called fusion. This generates heat to produce steam, which is used by a turbine generator to generate electricity. This atomic energy promised to churn out clean, safe electricity that would be too cheap to meter. About 23% of the overall carbon dioxide emissions worldwide is from transportation sector, whereas this number reaches to 28% for Canada. Our personal vehicles are a major cause of greenhouse gas emissions. Collectively, cars and trucks account for nearly one-fifth of all the emissions, emitting around 24 pounds of carbon dioxide and other global warming gases for every gallon of gas. About 5 pounds comes from the extraction, production and delivery of the fuel, while the great bulk of the heat-trapping emissions come right out of a car's tailpipe, and these emissions keep on soaring. After the Second World War, the military saw nuclear power not only as a means to defend or attack, but also as a means to get around. Nuclear propulsion includes a wide variety of propulsion methods by using some form of nuclear reaction as their primary power source. The first nuclear-propelled submarine, USS Nautilus, was commissioned in 1954. A multitude of ships, from aircraft carriers to icebreakers, followed ever since. The Nautilus was powered by an S2W submarine thermal reactor, a pressurized water atomic reactor capable of generating up to 10,000 kW. Despite the greater long-term range, nuclear power was cleaner and could potentially last forever. So it wasn't long until car manufacturers began looking into this technology. Ford's Nucleon concept is perhaps the best known nuclear car, even though it was never produced. In 1958, Ford unveiled an uranium-powered concept car with name Ford Nucleon, which has a scaled-down nuclear reactor at its back that heats stored water into a high-pressure stream to drive two turbines, one to power the wheels and the other to drive an electric generator. And this car had a speculated range of 5,000 miles. The passenger compartment was situated over the front wheels, allowing bulk of the reactor and the heavy shooting to be more centrally placed. Nuclear energy enticed the attention of space science. Nuclear thermal rockets conduct nuclear fission reactions similar to those safely employed at nuclear power plants. The energy is used to heat the liquid hydrogen propellant. A combustion propulsion engine would produce an exhaust velocity of 8,300 feet per second, whereas a hydrogen fuel nuclear engine would attain a velocity of 23,000 feet per second at the same conditions. Nuclear-powered spacecraft suggest that there is almost no radiation released from the nuclear reactors at the time of launch, since the nuclear-powered rockets are not used to lift off the Earth. Nuclear-powered sources could also be used to power the spacecraft with electrical power for its operations. There are some greater benefits of a nuclear-powered vehicle. Nuclear power is cleaner than fossil power, causes few deaths, and the space and weight saved from not having to carry fossil fuels would further increase efficiency and storage capacity. It has higher power and energy density, and a single fuel rod lasts so long that you would probably never need to refuel. Some of the biggest gains would probably come from nuclear-powered cargo ships. The largest container ships consume upwards of 10,000 liters of diesel per hour. It has been estimated that just 15 container ships produce as much pollution as all of the world's billion cars combined, and there are thousands of container ships currently at sea. Nuclear cargo ships would put a serious dent in global greenhouse gas emissions. With all that said, nuclear power isn't without its issues. The main problem is the radiation from the waste produced. Poor shielding could result in a messy end for the occupants of a nuclear vehicle, and any kind of containment leak would be bad news for the environment. Generally, the problem with good enough shielding is that it tends to be heavy. A small nuclear reactor is generally classified as anything that generates less than 300 megawatts of electricity. Even the smallest of 4th generation reactors, which pump out 25 megawatts of electrical power, weigh about 50 tons. A lot of that is shielding. On the other hand, the combustion engine in a car generates 150 kilowatts, about 200 times less power. For now, nuclear cars remain thoroughly unfeasible. They might not always be so though. There is a definite trend towards smaller and safer nuclear reactors. Nuclear technology holds the promise of significant benefits. However, it possesses a proportion of risks to life on Earth. This is why the Nuclear Energy Agency helps to create sound national and international legal regimes required for the peaceful uses of nuclear energy, including trade in nuclear materials, to address issues of liability and compensation for nuclear damage, and to serve as a center for nuclear law information and education.